subtle whispers of matter being consumed at its edge. This subdued activity makes it an ideal laboratory for testing Einstein's theory of general relativity in the extreme. Observations with radio telescopes, including the Event Horizon Telescope, have begun to pierce the veil around it, revealing a shadow-like ring, a silhouette cast by warped light bending around the event horizon. Surrounding this dark monolith is a region filled with turbulent gas, star formation, and enigmatic structures like the radio arc and the mysterious Fermi bubbles extending far above and below the galactic plane. These phenomena suggest that Sagittarius A* was not always so silent. In the past, it may have awakened in a storm of radiation, possibly shaping the environment of our galaxy on grand scales. Understanding the behavior of matter and light near Sagittarius A* doesn't just tell us about the Milky Way, it opens a window into the fundamental workings of the universe. Black holes stretch the fabric of spacetime, slow down time near their boundaries, and challenge the limits of physics. The closer we look, the more the ordinary laws of nature begin to falter. It is here, in this hidden core of our galaxy, that nature plays by rules we still struggle to fully comprehend. To peer into the realm of Sagittarius A* is to approach the very edge of what is physically possible. The black hole itself is surrounded by a region known as the event horizon, the point of no return, where gravity becomes so intense that not even light can escape. But this isn't just a boundary. It's a limit beyond which the known laws of physics dissolve into speculation. What lies beyond the horizon is unknown. A singularity? A bridge to another universe? Or something far stranger? Despite its invisibility, the influence of Sagittarius A* extends across thousands of light-years. Its gravity shepherds stars into tight orbits and may even help regulate the rate of star formation throughout the galaxy. As stars are pulled inward or disrupted, their material can be stretched and heated, creating spectacular bursts of radiation, brief but powerful echoes of cosmic consumption. Yet, these outbursts are rare. Sagittarius A* now appears to slumber, its feeding rate so low that it radiates less energy than a single household light bulb per unit mass. And yet, the quiet is deceptive. Evidence from surrounding structures hints at a violent past. The enormous Fermi bubbles, twin lobes of high-energy gas stretching tens of thousands of light-years, may be the fossil remains of an ancient outburst. Perhaps millions of years ago, Sagittarius A* blazed as a quasar, a beacon bright enough to outshine the rest of the galaxy. That light, long extinguished, may have rippled through the galactic medium, heating and shaping gas flows still visible today. More recently, astronomers have begun detecting ripples and flares from Sagittarius A* that arrive unpredictably, flashing in infrared or X-ray bands. These are likely caused by small clumps of matter, perhaps disrupted asteroids or wandering gas clouds, brushing too close to the event horizon. They spiral inward, heat up, and vanish. One such gas cloud, known as G2, was once thought to be on a collision course with the black hole, but it survived the encounter, a reminder of how much we still have to learn. The environment around Sagittarius A* is chaotic and extreme. Magnetic fields twist and tangle in invisible threads, and radiation bathes everything in energy. It's a place where stars are born and destroyed in rapid succession, where exotic objects like magnetars, neutron stars with ultra-strong magnetic fields, orbit perilously close to the brink of eternity. The interplay of forces here provides an unparalleled natural laboratory, offering astronomers the chance to witness physics pushed to its breaking point. Yet for all its darkness, Sagittarius A** may also play a role in galactic balance. Some theories suggest that supermassive black holes help to regulate their host galaxies, emitting enough energy during active periods to prevent runaway star formation and recycle material. In this way, the black hole at the center becomes both destroyer and creator, a paradox at the core of the Milky Way. As telescopes become more powerful and algorithms more precise, we are finally beginning to map the turbulent, crowded neighborhood of Sagittarius A** in exquisite detail. The stars that orbit near the black hole, often referred to as the S-star cluster, are like clock hands sweeping through spacetime. Each of their paths is subtly altered by relativistic effects, their orbits precess, their clocks tick more slowly, and their light bends as it climbs out of the warped gravitational well. These motions have allowed scientists not only to confirm the existence of a supermassive black hole, but to test general relativity with unprecedented accuracy, and so far, Einstein's predictions have held firm. Yet there is still much we cannot see. Some simulations suggest that smaller black holes, remnants of ancient stars, may swarm invisibly around Sagittarius A*, forming a dark halo that distorts the motion of stars and gas. These stellar corpses, spiraling in toward the supermassive center, could occasionally collide or merge, sending out gravitational waves rippling across the galaxy. We cannot detect them directly, not yet, but future observatories like LISA, Laser Interferometer Space Antenna, may be able to eavesdrop on these ghostly conversations between dead stars and the dark heart of the Milky Way. And then there's the matter of time itself. Near Sagittarius A*, time moves differently. An observer falling toward the event horizon would, in theory, appear to freeze from an outside perspective, forever suspended at the edge. But for the falling object, time continues normally, until it reaches a place where physics loses all meaning. This duality, where time stretches and bends depending on your point of view, isn't just poetic. It reveals something fundamental about the nature of reality, and how black holes might serve as windows into the very structure of the universe. Some researchers have begun to speculate that the information swallowed by a black hole may not be lost forever, as once thought. The so-called information paradox, one of the greatest unsolved problems in physics, suggests that our understanding of quantum mechanics and gravity may be incomplete. Could Sagittarius A** hold clues to a deeper theory, one that unites the macroscopic laws of general relativity with the microscopic rules of quantum physics? If so, the key may lie not in what we see, but in what remains forever hidden. Meanwhile, the black hole continues its silent reign. It does not glow, it does not move, and yet everything near it responds to its presence. It is a singularity, not only in space, but in mystery. A gravitational monarch ruling a kingdom of stars, whose throne lies buried beneath veils of dust and the whispers of ancient light. It is not merely the center of our galaxy. It is a portal to the edge of human understanding. From Earth, we can never observe Sagittarius A** directly with visible light. The galactic center is obscured by immense clouds of interstellar dust. But with radio, infrared, and X-ray observatories, we can peel back these veils and glimpse the invisible. Instruments like the Very Large Telescope, VLT, the Chandra X-ray Observatory, and the Atacama Large Millimeter/Submillimeter Array, ALMA, all converge their vision on this hidden titan. Their findings are astonishing: a maelstrom of plasma and magnetic fields, a region of gravitational shear and relativistic speeds, and light itself, bent into rings and arcs as it tries to escape. The Event Horizon Telescope's image of Sagittarius A*, released in 2022, was a milestone in this journey. Though blurry, it offered the first direct evidence of the shadow of the black hole, encircled by a glowing halo of hot gas swirling at nearly the speed of light. This shadow is not a simple absence of light, but a gravitational imprint, a signature of spacetime twisted into a vortex. The ring we see isn't the black hole itself, but the last orbit light can make before being swallowed. It is both a boundary and a symbol, a fiery crown for an invisible monarch. And what lies beyond the visible and theoretical borders of Sagittarius A*? Some physicists wonder if black holes like this are connected to the fabric of the wider universe in unexpected ways. Could the center of our galaxy also be the mouth of a wormhole, a conduit to another part of space, or another cosmos entirely? While such ideas remain speculative, they drive a bold frontier of physics where mathematics dares to describe what observation cannot yet confirm. The galactic center is also a crucible of extremes. Temperatures soar to millions of degrees. Gravity is strong enough to twist the orbits of entire star clusters. Particles accelerate to near-light speed in jets and flows, possibly spawning exotic high-energy phenomena. Somewhere within this chaos, dark matter may lurk, shaping the orbits of stars and influencing the motion of gas with its unseen hand. The very environment around Sagittarius A** may be a testing ground for understanding the dark scaffolding that binds the universe together. But beyond science, there is something deeply mythic in this region of space. Ancient civilizations may not have known what lay at the heart of the Milky Way, but they understood that the sky had a center, a place where stars thickened and mysteries dwelled. Today, with all our instruments and equations, we still stand at the edge of that unknowable center. We name it, model it, photograph its shadow, yet it remains a frontier not only of physics, but of wonder. Sagittarius A** is not just the center of our galaxy. It is the anchor point of a billion stars, the invisible axis around which the Milky Way spins. And in a deeper sense, it is a mirror, reflecting the limits of our understanding, the depth of our curiosity, and the immense journey that still lies ahead. As we delve further into the mysteries of Sagittarius A*, we are not just learning about a single black hole, we are uncovering the history, structure, and fate of the Milky Way itself. The stars that orbit near the galactic center are ancient, many of them formed during the galaxy's early epochs. They carry with them the chemical signatures of past generations, encoded like genetic memories in their light. Studying these stars helps astronomers reconstruct the story of our galaxy's formation, its violent mergers, its periods of rapid star birth and quiescence, and the central role the black hole may have played in shaping all of it. In recent years, a remarkable discovery added a new layer to this story, a compact cluster of young, massive stars, the so-called paradox of youth. These stars, known as the S-stars, orbit astonishingly close to Sagittarius A*, in a region where intense gravitational tides should prevent any gas from settling and forming new suns. And yet, here they are, hot, bright, and impossibly close to the abyss. How did they form? Did they migrate inward after forming farther out, or could they have emerged from the wreckage of a larger disrupted system? Their very existence is a cosmic riddle that continues to challenge astrophysical models. Some researchers speculate that the core of the Milky Way may host not just one black hole, but multiple compact objects, perhaps remnants of past collisions, hidden among the glare of stars and gas. Others wonder whether Sagittarius A** will one day become active again, igniting into a quasar that floods the galaxy with radiation. If a large enough gas cloud falls into its grasp, the black hole could awaken from its current slumber, feeding voraciously and reshaping the surrounding environment in a cosmic storm of light and energy. And while such an event might sound distant, its effects could echo far across the galaxy. The radiation from an active Sagittarius A** would not reach Earth directly. We are safely nestled about 26,000 light-years away, but it could impact the broader ecosystem of the Milky Way. High-energy particles, magnetic storms, and large-scale gas flows could influence star formation, rearrange interstellar matter, and alter the very structure of the galactic disk. Even now, some of the radiation emitted by the black hole, past or present, may be echoing back toward us after reflecting off distant